Hello everyone, welcome to my channel and welcome to another video on integration. In this video I have two integrals involving trig expressions that I would like us to look at. The first one is the integral from minus pi to pi of sine squared 3x dx. We are to evaluate this integral and I have a second one. But how do we approach this? Here is the approach to the first integral. So we have integral number one. It's the integral from minus pi to pi of sine squared 3x dx. Let's say this is page 1. Now looking at sine squared there, it should remind you of what we call double angle formula for cosine. So basically we are saying cosine of 2a is equal to three expressions. Cos squared of a minus sine squared of a, first expression. The second one is 2 cos squared of a minus 1. The third one is 1 minus 2 sine squared of a. Double angle formula for cosine. Now, if you look at this part here, we basically have it here in that space. You say, what about this one where we have cos squared there? Here we have sine squared only, so this would be the one to take. But now I want you to see something. If I have a here, it must be 2a. So if I have 3a here, I must have 6a there. So basically we are saying, therefore, cosine of 6a, if I'm allowed to use a again, this must be equal to 1 minus 2 sine squared of 3a. But what we have here is x. So we can simply say this implies cosine of 6x will be equal to 1 minus 2 sine squared of 3x. This is what I want, this part, because that's what I have there. So I'm going to have to make this part subject to formula as follows. You'll agree with me that we have 2 sine squared 3x. The answer will be equal to 1 minus cos of 6x. Divide both sides by 2. It takes us to sine squared of 3x. The answer is 1 over 2, open brackets, 1 minus cos of 6x. So this is the expression I want in that space there. So if you allow me to bring this integral down here and transform it, it will be as follows. The integral from minus pi to pi of what? Of this expression, half, open brackets, 1 minus cos of 6x, and we're saying dx. All I have to do now is distribute the integral and the dx, keep half outside, taking us to page 2. Basically, we proceed as follows. So, page 2, we are saying that integral now is equal to, keep half out, there is your half, and then we are saying, and I'm going to use a bracket here, the integral of 1, if you allow me to distribute that, dx, but it's from minus pi all the way to pi. And then I'm going to come to that, the second part, which is the integral from minus pi to pi of what? Of cosine of 6x. And then I have dx. I must just close that bracket there like that. Fantastic. Now we have to evaluate the two integrals separately. You'll agree with me that this is half of, this will be x evaluated from minus pi to pi, and there's a half here, remember. So I'm going to have to keep the, if I close that, the half must be distributed to the other side. So it will be minus half. And then I'm going to say, what is the integral of cos 6x? You'll agree with me, it is actually sine of 6x all over 6. And then we're evaluating this from minus pi to pi, like that. Now, here's how I approach it. Take the 6 out. So what we have now is 1 over 2. Here it will be pi minus pi. Remember, you're supposed to substitute. And then here I take the 6 out. it will be, remember the 6 is dividing, so this is 1 over 12, multiply 6 and 2, and then we're saying open brackets, and then we have sine of 6x evaluated from minus pi to pi, like that. Fantastic. Now, what do we have in the first bracket? 1 over 2 pi plus pi. The second part is 1 over 12. Remember, this will be now sine of 6 pi minus sine of minus 6 pi. Now, in the first bracket, we have 1 over 2 times 2 pi. What about this part here? You'll agree with me that this is 1 over 12. Sine 6 pi is 0. Sine of minus 6 pi is also 0. And what do we have? The second part falls off. And our final solution, therefore, is just pi. Because half of 2 pi is pi. And that will be 0 there. So this is the solution to the first integral. Just to remind you, our first integral, this one here, we evaluated this by using double angle formula there. Just understanding that if we have a square there, the easiest way is to get rid of this in terms of cos, using double angle formula for cosine. Right, let's look at the second integral in this one. Second integral taking us to page 3. Our second integral is this one here, page 3. Second integral in this video is this one. We are to evaluate the integral from 0 up to pi by 2 of cos 3x sine 3x dx. Now, it's very tempting to try and write 3x in terms of 2x and carrying on with expansion. It's going to be very difficult for you to handle that. So therefore, whenever you see a number here, 5x, 6x, or 3x, 4x, whatever numbers you have there, it should remind you of what we call the compound angle formula. So here is the approach to integral number 2. We have the integral from 0 up to pi by 2 of cosine of 3x sine of 2x dx. I'm going to remind you of double angle formula, a compound angle formula for sine, because we have cos sine, so it means we must use the sine one. So basically I'm saying sine of, watch this, capital A plus capital B equals sine of A cos of B plus cos of A sine of B. I hope you remember this. And I'm going to write the same one but with a minus sign. Sine of capital A minus capital B will be equal to sine of A cos of B minus cos of A sine of B. Now, I'm going to perform a little trick here, and the trick is, if you look at these two terms here, I'm basically looking at cos sine, that order, which means I must subtract the first equation, second equation from the first equation. So what do I have here? On the left, I have sine of A plus B minus sine of A minus B. You agree with me that these will cancel, but this minus sign will change that sign to plus sign. So what do I have on the right hand side? It's just going to be 2 cosine of A sine of B. If you look at this part here, is exactly similar to that part here, but I have a 2 out here, so I must divide by 2 both sides. So I'm saying basically this implies 1 over 2 of sine of capital A plus B minus sine of capital A minus B. This will be equal to cosine of capital A sine of B. Now, all I have to do now is to put 3x there and 2x there, and I must do the same on the left. So this implies half of sine of 3x plus 2x, watch this, minus sine of 3x minus 2x. This will be equal to cosine of 3x, and there it will be sine of 2x. Remember, we are putting here 3x, there 2x, like that. Simplifying the left hand side, we have 1 over 2, and this will be sine of 5x minus sine of x. Basically, this is equal to cosine of 3x sine of 2x. Now, fantastic. So this expression has to be replaced by that, and then we carry on with our integration. So therefore, that integral is going to be equal to the integral from 0 up to pi by 2 of what? Of 1 over 2 times sine of 5x minus sine x, like that, and then I have dx. Look at how easy this one is now. So I'm going to have to distribute, keep half out. I can actually distribute half and the integral and the dx at the same time. So we have page 4 now. So now what we have is that integral is equal to, so what we have now is, watch this, I'm going to now say half of the integral from 0 to pi by 2 of sine 5x dx minus half of the integral from 0 to pi by 2 of what? Of sine x dx. Fantastic. Now let's evaluate the two integrals separately. You'll agree with me that this is 1 over 2. The integral of sine is minus cos, but we have 5 there, so we have to divide. You can actually verify that by using u substitution. So basically, I'm saying half of what? Watch this. Cosine of 5x. Integral of sine is cosine, minus cosine, like I told you. Integral of sine is minus cosine. So we have 5x there, and we have to divide by 5. We are evaluating this from 0 up to pi by 2. First part. Let me go to the second part. Minus 1 over 2. And the integral of sine, like I told you, is minus cosine of x. We're evaluating from 0 up to pi by 2. Like that. Now, take the minus 1 over 5 out. So it will be minus 1 over 10. Because you're multiplying, minus 1 over 5 times half is minus 1 over 10. And you're saying cosine of 5x, we're evaluating from 0 to pi by 2, like that. Take the minus out, you can have positive 1 over 2. And you're evaluating this from 0 up to pi by 2, like that. Now, plugging in pi by 2 and 0, we have minus 1 over 10, like that. Open brackets, cosine of 5 pi over 2 minus cosine of 0, and then plus half. Here we have cosine of pi by 2 minus cosine of 0. Now, cosine of 5 pi by 2 is 0. Cosine of 0 is 1. I'm going to show you just quickly here. If I may get a separate page, I'm going to try and get a page from down here. Remember, 5 pi by 2, it means 2 pi plus 2 pi plus pi by 2. What is the meaning of 2 pi? It means if this is your circle, you started from there, you have gone round and you're back to the same position. So 2 pi is equivalent to 0 in terms of if you have cosine there or sine or tangent, whatever the case may be, that will be equivalent to 0 also. And so this one simply breaks down to cosine of pi by 2, and that is 0. Cosine of 90 degrees is 0. So that is 0, and that is minus 1 there. So you can have minus 1 over 10, open bracket, 0 minus 1, plus half. Same story here, this is 0 minus 1. This part here will be minus 1 over 10 times minus 1 plus half times minus 1. This is 1 over 10 minus half there. And this, if you agree with me, it's 1 over 10 minus 5 over 10. That's minus half. And this is minus 4 over 10. You just subtract the numerators because denominators are the same. Simplifying this, it gives you minus 2 over 5. That's the final solution to our second integral. Just to remind you, integral number 2 was this one. So second integral is that one. and we had to do a little trick there using compound angle formula there, and we are able to evaluate this. So these are two integrals that are prepared for you in this video. Just the beginning of a series of integrals I'll be evaluating involving trig functions. Tell me what you think, your comments, your feedback. We truly value that. I'll see you in the next one.